Welcome to another video, the same every time, IGCSE Maths, GCSE Maths, looking at the kind of questions that, apart from the numbers, are the same every time. We're still looking at speed-time graphs, and here's our speed-time graph for this particular exam question. And if you've watched the other videos, you will hopefully remember that the first thing I suggested we do is just check that the units actually match up, because if they don't, we'll have extra problems here. So the speed on the vertical axis, meters per second, and the time on the horizontal axis is actually given to us in minutes. So now we have an additional problem because the units don't match up. Seconds and minutes, they do not match up. Okay, that's easy enough to deal with though, remembering that the usual units for time would be seconds. All I have to do is just change my axis, or change the labels on my axis, my horizontal axis for the time. So time in minutes, I actually want this to be seconds to match up there with the meters per second. So 1 minute, that would be 60 seconds. And then 2 minutes, 120 seconds. 3 minutes, 180 seconds. 4 minutes, 240 seconds. 5 minutes, 300 seconds. And 6 minutes, 360 seconds. So I'm just making sure that my units are matching up. So meters per second matching up with seconds on the time axis. So a train leaves a station, accelerates for 2 minutes. That's the positive slope, the positive gradient, until it reaches a speed of 12 meters per second. It continues at this speed for 1 minute. So constant speed is the horizontal part of the graph between 2 and 3 minutes, or 120 and 180 seconds. It then decelerates for 3 minutes. That's the last part of the graph where we have the negative gradient, the negative slope, and stops at the next station. Calculate the distance in meters between the two stations. So that's why we need to have our units matching up, because if I have my speed in meters per second and my time in seconds, my distance is going to come out in meters. So the units for the time have to match up, seconds and seconds. Remembering that distance traveled on a speed time graph is the area under the graph, and we can split this into 3 shapes. So we have a triangle at the beginning, rectangle in the middle there, and we have another triangle just there. So triangle, rectangle, triangle. And we can work out the area for each of these. So my first triangle, the base is going to be 120 and the height is 12. So base times height, 120 times 12, divide by 2. That's the first triangle. And the rectangle, the base distance from 120, remember we have to work in seconds, 120 to 180, that would be 60. So the area of the rectangle, base times height, not with a divide by 2 because it's a rectangle. Then we have the final triangle just here. So from 180 to 360, well, the base of that particular triangle is 180, isn't it? 180 to 360, and the height is still 12. So base times height, divide by 2. So the distance in meters between the two stations, my whole calculation then, 120 times 12, divide by 2, plus 60 times 12, plus 180 times 12, divide by 2. And, well, calculate a job for this one, whatever this turns out to be. That's going to be my final answer. So 120 times by 12, divide by 2, plus 60 times 12, plus, and finally 180 times 12, divide by 2. And that gives me 2,520. So the distance in meters between the two stations, 2,520 meters. Notice how I've shown all my method there, showing that I know that I should be calculating area under the graph. That's where the method marks are for knowing that you should be calculating an area. Yes, I suppose we could just type the whole thing onto our calculator, but that wouldn't be very wise. If the video was useful, then please do like and subscribe because that's useful to the channel. Thank you very much for watching, and I will be back with the next video.